Hello everyone, a very warm welcome to everyone present over here. I'm Namrata Hari from SRMIC Ramapuram. Hack the Mountains 2.0 welcomes you all for the session. It's really nice that all of you have taken off your time to attend this session and learn something new. Let's continue having the spirit for this event and for the upcoming events as well. We are delighted to announce that we have Lumos Labs as our sponsor for our hackathon this year. They have brought a session on the topic Smart Contract Development on N3 with Stephen. Stephen is the team leader at NGD. His experience in the field makes him more than qualified to guide you through this workshop. If you hackers want to know how to use Neo N3 in your hackathon project, this workshop is perfect to ask any questions related to Lumos Lab, and the best project gets the chance to win prizes worth 22K and other exciting prizes from the blockchain for beginners with NeoTrack. You can check out further details at our Hack the Mountains website. If you have any questions, ask away. Without further ado, Hack the Mountains team welcomes you, Mr. Stephen. Over to you. The stage is all yours to rock.
Okay, thank you. Thank you, guys. Hello, everyone. My name is Steven, and I'm the tech leader of NGD Shanghai. And today I'm very happy to give a workshop talking about the development on N3. And now I will share my screen and turn off my camera. Okay, I think you guys can see my screen, right? Okay, now it's my today's workshop. Today I'm going to give you an introduction about the development on Neo blockchain. I think today's workshop will come up with some like the story of Neo, the theory knowledge of Neo, the upcoming Neo 3, and the example of smart contract development on Neo 3. Okay, first of all, let me introduce about myself. My name is Steven, and I'm Chinese. I'm technologist of Neo Foundation, and I'm tech leader of our DeFi protocol Flamingo, and I'm head of development in NGD Shanghai. I work for Neo since 2018, and personally, I'm a software engineer and a DApp developer. Okay, first of all, I may introduce a little bit about the story of Neo, the very famous public blockchain in the world. I think before that, I may explain a little bit about my understanding of the current blockchain world. I think everyone knows Bitcoin here, right? From 2008, the Satoshi creates he published the white paper of Bitcoin. And from my point of view, Bitcoin is not something new. It's just a example of some technical things from the traditional computer science world, like a system metric encryption, the hash encryption, the proof of work, these kind of things. And he combines all of these things to a peer-to-peer distributed ledger to build a distributed trusted currency system and a payment solution. I think Bitcoin is the most important in the crypto world. And until now, I think a lot of countries, large companies, they're looking forward to use Bitcoin to as in their currency system as a payment solution. But as the in the because of the limitation of the function, Bitcoin can only use in the payment, in the trading, but it cannot be used very widely in the business field. Now comes up with blockchain 2.0. Here I make this title. In the 2.0 blockchain, we have Ethereum, EOS, and Neo, of course. What's the new things here in this stage? It's every blockchain has a Turing complete machine and extended script language that let people can do some development on this blockchain world. And Before that, you can do trading and do payment with Bitcoin. But based on these kind of blockchain 2.0, you can build a lot of things, create smart contract and D apps. Uh, in this stage, blockchain is more like a operating system, and it provides a lot of API and interface, and people can do a lot of apps and implement business logic based on this. Now, people are more talking about the blockchain 3.0. What's the 3.0? I think some people say it's like quantum computing. Some people say it's like a lightning network, a sharding, these kind of things. From my point of view, the 3.0 is still not very clear, and we still have to like take a lot of time and resource to investigate on yet. But with the blockchain 3.0, I believe the blockchain applications can be used in a lot of areas like the finance, government, scientific, and artist maybe. So in blockchain 3.0, the blockchain can have the ability to handle the enterprise level business applications. That's my understanding of the current blockchain world. Now let's talk about the Neo blockchain. I think Neo is very famous. Maybe you guys heard a lot about it before. Neo, we begin it from 2015 by our founders, and it's open sourced in the beginning, and it's globally developed. We have core developer team around the world, and the target of Neo is to use the smart contract digital asset to digitalize the real world asset on the blockchain and use the digital identity to make it on chain and do the digital economics. That's the goal of the NEO in the beginning. That's called the smart economy. And this is a storyline. In the beginning, we called on share, and then we open sourced on the GitHub. And 2016, we launched the mainnet. And from 2017, we rebranding to the Neo, and we have our token standard released. 2018, we hold our DEFCON, and 2019, we hold our second DEFCON. We have our new branding design, and last year we do a lot of things like we have our DeFi protocol Flamingo, and we also joined a cross-chain protocol with another blockchain called Poly Network. And this year we are going to launch the N3. I will talk more about it later. So as I said in the before, Neo has famous for a lot of years and it grows every year. We had a lot of things in the ecosystem, a number of wallets, a number of infrastructures, and also a number of D apps and DeFi protocols. And the Neo is going to build a great developing ecosystem, and you can see a lot of exchanges list Neo and NEP5, and almost every wallet support it. And we have huge daily transactions and the apps daily users, and we have our global communities. Yeah, and here is some view of our global community. You can see a lot of community around the world, and we have our strong social medias. As I said, Neo is globally developed. We are not only based in Shanghai, we are also have office in Seattle, and that's the NGD team. In addition to that, we also have our community team, like we have the Neo Research based in Brazil, Refosec based in Spain, X Labs based in Zurich, NSTCC based on St. Petersburg, City of Zion, they are based in Europe and America, and Neo Tracker based in Seattle. Yeah, all of these communities contribute a lot to the Neo, and we are looking forward to new teams and new starters to join the community, and hopefully we can have some new face in India. Now I think the story of Neo is almost finished, and now I will talk a little about the theory of Neo. First of all, Neo has a different consensus algorithm. You guys may heard about POW, proof work in the Bitcoin, and the Bitcoin is using the proof work, which is sounds like if you want to produce a block, you have to do a lot of work, do a lot of computation, which means you have some cost if you want to produce a block. And the probability is that the transaction will not be reverted because if you want to revert a block in the Bitcoin, you have to cost a lot of resource. And the POS is called economic finality because that means you have to hold a lot of economic expenses for a block to be reverted. And why Neo use DBFT, which is a BFT related algorithm, because it's absolute finality, and it's also called single block finality, which means when the transaction is created and packed into the block, it's finalized and included immediately and have no ability to revert. That's the DBFT algorithm. It's very good for some financial applications. And the DBFT algorithm has a number of steps. First of all, you people can send the transaction to the network, and the consensus node will receive this transaction and put in the memory pool. Then the speakers of the consensus will pack this transaction and starts by broadcast a prepare request message, and it will broadcast to reward. And also the delegates will receive the proposal, the block, and verify it, and also broadcast the prepare response after receive it. And all the other validators will broadcast commit after receiving enough prepare response message. Finally, when the validator produce and uh, uh, when the validator receive enough commit message, it will produce and broadcast the new block. And then it starts the next run consensus. And in addition to the DBFT consensus algorithm, we also have a number of new utilities and new features for the new platform other than other blockchains. For instance, we have our uh, two token models. NEO is the governance token, Gas is the utility token. We have our digital asset standard called NEP5, and also we have our NFT standard. Neo is a multi-language smart contract supported. I will talk more about this later when I talk about the smart contract development. And we have our own designed Neo VM, and it's our Neo's unique universal lightweight VM. And we also have Neo ID. It's a decentralized trust network. So people may interested in the Neo VM. Neo VM is a lightweight virtual machine for running the new smart contract, and it's highly decoupled with the app level code, and you can run it independently. And it can be simply create an instance of new VM, and people can easily use it, and you can even use it in another blockchain and blockchain scenarios. And I will talk more about new VM now, about its structure and its running process. So this is a more clear picture. So new VM is actually three main parts of it. The first one is execution engine. The second one is the stack. The third one is the interoperation service layer. So the execution engine is the core of the new VM. It's mainly responsible for loading the scripts and executing the corresponding instructions. such as the flow control, stack operation, bit operations, these kind of things. It's like the core, like the CPU of the machine, and it also can interact with uh, other two parts. And here we have the stack, and the new VM is a stack-based virtual machine, and it has three types of stacks: the invocation stacks, the evaluation stacks, and the result stacks. And the invocation stack is to store all the execution context of current VM, and the evaluation stack is for storing the data used by the instructions, and the result stack is used to store the result after all the scripts executed. And in addition to the execution engine and the stacks, we have the inter-operation service. The inter-operation service is a bridge between the VM and the external data. So by if you use the inter-operation system in the smart contract, the Neo VM can access like the broker information, the transactions, the headers, and other data. And also we have our private storage for each contract. You can also use inter-operation service to interact with this private storage. So what is the smart contract in the new VM? Here I put an example. It's a very simple function, like it's a it's the function called test, and it's just a return one. And after compiling it and putting it into the new VM, you can see this is a compiled thing. It's just a one digital string, and when it puts to the new VM, it will be translated to a number of OP code like init function and push one yet, and put it into the result stack and return back. So after all, the smart contract itself is just a sample of OP codes. It's not something difficult or something hard to understand. It's just like your normal uh, computer science related program. It's just a sample of OP codes and running in the new machine, virtual machine. So what's the new virtual machine execution process? I think I can turn back to the previous slides with this picture. So first of all, you can write the smart contract with different high-level language like the C Sharp, Java, Go, JavaScript. We support all these kind of high-level programming language, and then compile it to the OP code with different supported compilers. And after you compile the resource code to the smart contract and with the unified bytecodes, it will be stored in here in the storage area, and the execution engine of the virtual machine will load the bytecode file and construct this byte file together with the related parameters and create a execution context. And each time execution engine takes the instruction from the current context, it will running the corresponding operations according to the instructions, and the data generated will stored in the evaluation stacks. And if the smart contract use some external data and other operations, it will use the inter-operation interface. And after all these scripts are executed, the results will be stored in the result stack. Yeah, that's the whole process of how the smart contract running in our new VM. I will, in the final part of this workshop, I will give you some example of how how the smart contract is work and compiled and running with the result. I think that's the main part of the concept of new blockchain. And now we are going to upgrade our Neo. Before we called it Neo 2, and now we are going to upgrade, and it's called Neo 3 or N3. And it has a lot of new features, and I will introduce a bit. Okay, first of all, we update our vision. Now Neo is uh, like it's an open source community driven blockchain platform, and our vision is still the same as before. Like we want to be open network for the smart economy, and our mission is to make any asset, digital or physical, accessible by the human beings and programs with minimized trust and permissions. And that means developers can digitalize and automate the management of assets through the smart contract. And with our strong, powerful infrastructures and decentralized storage, oracles, NNS, and these kind of things, we can build out the next generation internet. And these are some details features we have in the native in our N3. The first of all, we build our native contract. So what's native contract? Before our Neo and Gas, all the other things like the Oracle things, we are doing uh, some kind of hard code or some things. Now all of these are native contract rather than building the Neo hard code. That's more efficient and has less limitation, and also it's compatible with the new NEP5 standard before. And also we abandon our UTX model to enable Neo and the gas in the smart contract. And so when people develop things with the smart contract, it can access to this native contract directly. That's very friendly to the new developers. Second is our DBFT upgraded 2.0 version, and it is much better and healthier. And we improved a lot of memory pool performance and reduced the operational burden on the network. And that means we reduced our average block time with the DBFT 2.0. And in three, we have new FS. So the file storage is a very important thing in the blockchain world. You may notice that in the traditional internet world, people are more concerned with the large scale data and not only about the storing of data, but also care about the privacy of the data, the security of the data, these kind of things. And in the N3, we have our native supported file storage called NeoFS, which is developed by the Neo St. Petersburg team. And they are building a NeoFS, Neo-based file storage, can let people interact with the file storage directly from the smart contract. And it has a lot of features like the fault tolerant and user controlled privacies and geographical and network scalability, and also has a lot of third-party service integrated. And it's very great for the Neo ecosystem because with the Neo FS, people can build more larger scale business applications as the current internet world with all these large and important data stored in the Neo FS. In addition to that, Neo also have Neo ID in the N3. This one is developed by the Neo and the Swisscom blockchain together because when people use the blockchain, they have a lot of concerns with their identity because before most of the users just create a wallet and interact all the activities and smart contract with the wallet. It's great, it's anonymous, but people have some in some scenarios in some DApps they are still very important to know the customers and know who he is, know his behavior. So in the new ID, we create a trust model identity solution, and the people can hold it, their privacy, can protect their privacy, but still the identity and their uh, their information can be still verified by the DApp users and also authorities. In this way, people can use the new ID to do some KYC based applications or some credit or reputation based applications. That's the new ID feature on the new 3. And in N3, we also have the interoperation ability. We, with other blockchain like Ontology and Zelica, Switcher, we build a Poly network, which means the asset and the transactions on Neo blockchain can be transferred, can be interoperated in other blockchain. And the same way as the other blockchain's assets like Ethereum, Bitcoin can also transfer through the Poly network to the Neo and do the related transactions. And it's very great. We already use it in the last year for the Flamingo Finance, and a lot of assets come to the Neo blockchain world and do a lot of financial activities here in the Neo. I think in the next 2 or 3 years, interoperability is a very important thing for the blockchain world because not only one blockchain can work and finish all of things. I think all the blockchains in the world will connected with each other and interact with each other. Okay, I think that's all for today's slides. And for our next one, I will introduce a bit about the real things, how to develop and how to interact with a smart contract with some small examples and demos. So maybe you guys may want to know like what is smart contract. The idea it's very old. It's almost established in 1994, and now with the blockchain, the smart contract idea can be implemented on the blockchain. And you can thinking about it as a vending machine. You put something as import, you get some thing confirmed and trusted output. That's how the smart contract works. And the smart contract is like autonomy, trust, robustness with highly decentralized, and also uh, because it's decentralized, you also have economy because you don't have to involve lawyers or other like witness intermediators. And in Neo, we support a lot of high-level programming languages like support C Sharp, Python, Java, Golang, and JavaScript. All of these languages are supported in the Neo blockchain. And the smart contract is very simple. It's not some complicated things. Here, I just put some two very easy example. Like the first one is a C Sharp example. It's just to show like how to write a main function and return true. And the second one is the Python example. It's just put a string value into a storage. It puts the hello as a key and the word as a value. And also it implements a hello method, a hello function, and returns the string back. That's the two very simple example, and I will try to run these two example later in the demo. So why smart contract? With a smart contract, people can run their user-defined behaviors and activities like to do the token exchange, manage the identity, manage the storage, or do some like online voting, these kind of things. And in Neo, besides the smart contract programming language, we support a lot of we developed a lot of tools like the Explorer and smart contract develop IDEs, the wallets and SDKs. We also provide some private net solutions. All of these tools can let the developers join the Neo development very easy. So I think that's all for the slides. Now I will try to give you some demos, and I will quit the share and with some demo. So first of all, I will start the private node. Well, because in the blockchain, you may have the do it with mainnet, or you can test it on the test net. But I think in the beginning, the most convenient way is to do that on the private net. So in the documentation I shared with you, it's very easy to start up a private net, and because Neo is based on C Sharp, I use the C Sharp version, but you guys can use the Python version or Go version. It's both okay. I use the C Sharp version, and you just run the .NET and Neo CLI, and it's my private net. It's running already like 1 day or 2 days, prepared for this workshop. The blockchain height is almost 99,000. And then you can see it's running and it's producing the blocks. And now let me create, open the demo I have already created. It's a C# demo, and it has a number of templates you are included, and here is some basic information you want to include it in the manifest, and here is the main function of the smart contract. I create two functions. The first one is called deploy, and this function is executed immediately after it's deployed, and it will put something in the storage. Here we can change it. We say we store the workshop, and the key is hello, and also I implement my personal method. It's called my method, and it will get the value from the storage, and after that we can compile it, and let me open the another terminal. It's another Neo CLI, and I have to run it. And in order to deploy the smart contract, first of all, you have to open the wallet. Here I have already created a wallet, and that's open yet. Okay, it's opened it successfully, and let me let's check how much it has. Okay, I have already some Neo and gas in yet, and every transaction in the Neo N3 it costs gas, and if you want to deploy the contract, if you want to invoke the contract, you have to use the gas, because gas is the utility token in the Neo ecosystem, and then you have to use the gas to deploy the contract and invoke the contract. And let's first, after we finish this, we have to compile it. We open it in the terminal here in the VS Code, and we just use the .NET build to compile it. Okay, we can see here we have already compiled it directly and it will be generated. Okay, here we can see it creates two files here in this bin folder and the sc folder. We have two files. The NEF is a smart contract compiled file, and here we have the manifest, which is the general information of the smart contract, including the names, the groups, the supported standards, and the ABI files also included in it. What we have to do is we have to deploy this NEF to the private chain directly. So let me first check what's the files path of it, because if you want to deploy the source files, the compiled files to the CLI, you have to know the detailed path of it. Here we just call deploy and paste the path we created. And what's the name of it? It's called workshop1.nef. Workshop1.nef. Okay. And it says this one is the contract hash of your smart contract. If you want to invoke it, you have to remember this. And it says it will cost you about 10 gas to deploy this one, and also it will cost this gas because it's a transaction. You have to pay the net fee, and we say yes, and it will be signed and relayed to the transaction, and the transaction will be running in the my private net. Okay, I think the next block is already produced, and it's here. We can see there is one transaction, which is the deployment transaction. Now I want to invoke it. So before, as I said in the source code, you can see the function here. We have a deploy function, and it will be executed immediately after the contract is deployed. And in this function, we put the hello as the key and the workshop as the value. Now we want to call this method to get the hello as the key stored value. So what we need to do is we have to invoke this smart contract and invoke the function. So we just invoke, and here we have the contract hash, copy it and paste it. And we have to call the my method. Okay, we can see here is the outcome. As I said, it's the result stack in the virtual machine. We already get it. But the value here is very strange because it's base 64 encoded, and we can use the converter here. We create some convenient tools to convert. We convert here and we convert to the base 64 decoding. We can see here is the value is called workshop. Okay, that's very simple, right? That's our first demo of the C# based smart contract. We can also use the Python one, if someone is familiar with Python. Okay, for Python, it's much easier because you don't have to install a lot of dependencies as the .NET. You can just install the BOA3, which is the toolkit and compiler for the Python developers of new smart contract. And now in the Python smart contract, we also create two functions. The first one is called init. The second one is called hello. And we also change a bit. We use the key as, okay, we use the mountain as the key. We want to get the value of it. We don't use the word as a value. We can create a hexagon as value. And okay, that's all for the Python smart contract. I, I just save it, and what I have to do is to compile it. Let me open the other terminal, which is already has Python environment activated. Let me find the Python. Okay, it's py walk. Okay, let me first delete all these things. First. Okay, I just delete some old files and we just leave this Python file, which is we can see which is just the uh, source code I just created, and we use the new3 borrower to compile it. Okay, it says hello world.nef is created. Let's check here, and we can also use the new CRI to deploy it. I think it's almost the same as I displayed to you guys before. It's the same process because the C sharp smart contract and the Python smart contract, they will be both compiled to the same bytecode running by the new VM. So the other kind of deployment and invoke case are the same. Because of time, I don't want to run it again. That's uh, that's the Python example. And let me back to the slides. And so generally, when a D app, uh, what's the D app composed of? A D app composed of a smart contract. You have to write it and compile it, and you have to find the network to deploy it. You can do it with private net. You can also do it with testnet or mainnet. And finally, you have to build some website to some front end to interact with it. Like the CryptoKitties, you have to build some very cutesy things and some payment page to let you either buy it or sell it or interact with it. That means we have to use some front end and some wallet extension to interact with it. Here I also build an example about how to use the wallet extension and JavaScript to interact with the smart contract on the testnet. I'm not a JavaScript developer, but I have some examples already using the React uh, framework. And here we can see a new demo here. So what we have to do is just include a NeoD API from the npm package, and we have to store. Let me minimize the screen. We have to store the Neoline wallet extension because this extension supports the DAPI, and you can choose the testnet to run the applications. Here uh, we go to the project, and let's run the demo for young start, and it will running the React applications. And okay, it will open the web page. You can see this is a very example demo, and what we did in the demo is just like I call the get balance DAPI from the wallet DAPI, and I provide address and some contract. That means we can call the function to get a balance and check the balance of these two kind of assets on this address. And I just console.log of it. instead of updating some UI things. It's too much work for me. I think something wrong maybe. Okay, just refresh it, and okay, we see here is the demo, and we open the console, clear the unnecessary message. We connect the new line, and you can see the new line extension will just pop up, and you connect to it. Now you are connected to new line to this demo applications already, and you can also get the balance of it, which is the function I just displayed. And you can see it is the outcome, and here is the two balance of my address. It's the neo balance and also the guest balance of it. And for the DAPI, there is documentation, and you can do a lot of things like invoke the contract, read the contract, these kind of things. That's all for the new line and the front end DAPI demo. And now I think go through this examples and the demos. Maybe you have some like brief preview of how to work with smart contract and dApps on Neo and on 3. And that's all for today's my workshop. And welcome to any questions you have. And I'm very glad to answer your questions and provide some helps. And thanks. I can stop my sharing.
Yeah. Awesome session. I guess we got some questions from Shiva Pandit. I am new to hackathon. Where can I find the problem set? I guess this is more related to our hackathon. You can definitely check out the different tracks we have on our hackathon website. Check out the Lomos Lab track that is like blockchain for beginners. This is the workshop we are having now. Then another question we have is from Liu Pifang. Thank you for sharing this information with us. Would you like to give us some suggestions on what kind of smart contract that we can make in daily life scenario?
Daily life scenario. Okay, I think for daily life, well, I think you can create some. Let me think about it. Maybe some NFT related things, which is very popular now. You can like link the digital asset to some real world asset, like the artist or some very expensive leisure luxuries, and make it digitalized as NFT, and to make it online. People can trade it to store it. These kind of things. That's my idea.
There are another question from Ashwini Kumar. Can you suggest some of the examples of smart contract? How can we use that?
Can you suggest some examples? Well, I think so. The question is like give some examples, right?
Yeah, she's asking some examples like how we can use it. I guess that's what she's asking.
Okay, I think I can. I think according to the, I think we already provide some links here in the docs or in some tutorials. Here we already include some examples. Maybe you guys can check.
Yeah, we have put it in the comment section. You can definitely check them out. Then there were a lot of questions in Discord. I guess your teammate has answered them all.
Yeah. If you have any questions, we are also available on the Discord, and you guys can also ask us. Me and my colleagues were both online.
Sure. So I guess that's it. Thank you, Stephen, for taking your time
Thank
off
you.
your busy schedule for being with us here. It was amazing to hear out all the information you had for us. I'm sure our audience also loved listening to the session. Um, Before we sign off, don't forget to check out the Blockchain for Beginners track and join the Lumos Lab community. You will be able to find all the details regarding the track on our hackathon website. If you have any further doubts, ask away in Discord. Some important announcements are that our hackathon registrations close at 4 p.m. IST on 27th June. That is day after tomorrow. So if you haven't registered yet, register soon at our Hack the Mountains website. And if you have registered for the hackathon, don't forget to fill up the check-in form. It is compulsory to fill that up. You'll find the link in the Discord server too. Also, to grab your Hack the Mountains participation certificate, fill up the feedback form so that you can get them. So I guess that's it. Thank you, Steven, for being with us. It was really lovely having you all here.
Thank you.
Bye.
Bye bye.